Moin, this video is part of the scientific Python programming lecture at the University of Bremen. In this session and the next one we want to have a look at container data types. If you remember from last time, we had scalar data types. For example, we had scalar numbers like real numbers, integer numbers, complex numbers even. We had also strings and logicals, and those were all kind of scalar data. And now we want to look at the kind of composite data types, so more complex data types, so-called container, where we can throw in different type of items. This session will be, as always, made in a way that you can follow it immediately. So I would suggest you to start your virtual box, and within your virtual box, your Ubuntu environment, which we configured for the course. And then you can do it step by step. Whenever I do something, you can just follow it. I already did that. I started my virtual box, and this is exactly the environment you see. And I have already also downloaded the slides, and the slides can be found at the usual place. As you know, this is the URL from that, and we are at chapter 3, container data types. If you have a look at the outline, you see that we will basically have a part of a small comment on comments. We will deal with so-called tuples, lists, and dictionaries, and also some string methods and some arithmetic with those operators. That's the outline of the session for today. Basically, before start, maybe let me just make one comment on the comments. That's the first thing. When you just write programs, you should sometimes write comments. You remember maybe, or if not, I just tell you that in Python comments are started with hash mark. Whatever follows after that line in the comment will be completely ignored by the interpreter. And this you can use to add some comments which are necessary to understand the code. However, you should make sure that you have only a few comments, because actually it is your code which should be self-documenting. So you should write a clean and very easy to understand code so that people can understand what happens there even without having to look any comments. Comments are usually very handy if you do something which is non-trivial. Like, for example, if for whatever reasons, in Python we start indexing by 0, if for whatever reasons you had an array or an index where the index starts by 1 and you would have to create increase this index by 1, then this is maybe not straightforward, so that deserves a comment. But never ever try to make a comment which is completely trivial. For example, here having a for loop which runs over some range and then writing the same in the command, because basically whoever understands Python will exactly know if you have such a for loop which runs over all the items. So basically it should be always the program which tells a programmer what it does, and only if you have some non-trivial tasks, then you should make comments on that. Okay, good. Now let's start with the actual topic of this session, which are the container data types, and we will start with the tuples. And in order to make sure that you can basically do everything what I do, let's first start an LX terminal, a command line window, and this command line window, just let's start the Jupyter Notebook, so that make sure that you can follow whatever I do. If you enter Jupyter Notebook, it will be also start your browser. And once your browser is started, you remember you can basically create a new Python worksheet by going on new, clicking on new, and then selecting Python 3. And I would also suggest, if you start this new worksheet, maybe to rename it, because usually the name is untitled, which is not a very practical name, especially if you start a new one, it will be overwritten. So let's call it chapter 3. So basically, because this is chapter 3. This will contain everything which we will add in chapter 3. So let's go back to the slides with Alt-Tab, switching between the windows, and you see the first line is about the tuples. So what are these tuples about? These tuples are basically nothing as just containers where you can, in an ordered way, put in a tuple whatever you like. So what does it mean? Let us have a look. Let's define a tuple T1, and then I will just enter various items like 1, a number. I will enter a string like hello. I will enter a floating point number 9.8, whatever. Tuples can be recognized by this parenthesis. So basically the elements of a tuple are always within a parenthesis, or usually within a parenthesis, and they are separated by commas. By commas. And if you just execute it, and then you say T1, you show the content of the T1. You see this is nothing else, just the thing which you entered at this very moment. Okay. Sometimes you can leave away these parentheses if the delimiters are or the delimiters, the parentheses, if it's unique, is it not ambiguous. So you could also have written T1 is equal, let's just go back and remove them. It's clear if you have something which is here separated by commas, then basically it's the same, it must be a tuple. Okay. It is also possible to have an empty tuple, which is just basically nothing else, just the parentheses up, opened and closed. And then if you say T2, then it's indeed the empty tuple. And the length of the tuple, similar to a string, you will remember maybe the strings, they were containing characters, tuples are containing arbitrary items. Similar to the strings, you can get the length of the tuple, which means the number of items within the tuple, just by the length function. So if I apply to T1, I get 3. If I apply it, for example, instead of T2, which was the empty tuple, then I get 0. Now, just going back to the question of how do we do that with the parentheses and the commas, you see here in the example in the slide, if there could be an ambiguity, if you, for example, try to define a tuple, let's call it T1 bad, and then we just say, okay, it should have the element 1. Now, if you do this way, that's not very good, because Python will be not able to decide whether this 1 is just an arithmetic expression put in parentheses, or it is supposed to be a tuple. And actually, if you execute that and then have a look on T1 bad, you see that it's not a tuple, it's just a number 1. In that case, it's obligatory that you are, even if you have just one element, you are adding a comma so that it knows. So basically, if let's call it T1 good, and then we are just saying, so Python, if you add this comma, then Python will know that basically this thing is meant to be a tuple, and then no, if you are hitting enter, then you can see the value that it's indeed a tuple. Actually, if you have a tuple which is longer, has more than 2 elements, more than 1 element, 3, 4, whatever, also there you can have a trailing comma if you need, then it's not a syntax error. So basically, you can always add a trailing comma to make sure that it's a tuple and not an element, not an just a scalar, a number in a parenthesis. Okay, how can we, now we created the tuples, how can we basically put into the tuples the various elements, or how can we access the various elements? And basically this is exactly the same as we had with the strings. You remember in the strings we had characters, and we can access the various characters by using the square braces and indicating the position. We had to remember that position in counting of the position starts with 0, and this is exactly the same also if you want to access elements within a tuple. You can just have a square brace and indicate the indication of the position. So let's have a look at an example. Let's have a look at the let's have a look at the tuple which we had before. Let's say T2, and then if you get the zeros element of T2, it gives you just 2, or the first element, which is basically a second, because you know counting starts with 0, is the second. Similarly, how we did with strings, you can have also ranges. So if you want to from the 0th to the third, you know that it will give you 3 elements. The first one will be included, the last one, the upper bound, is always excluded, and that gives you basically a tuple. Just to remember, that was the original tuple T1, and then T1 0.3 is basically the entire tuple. Now let's just take a subpart of it, 0 to 2, then it's basically, you see, it's just the 2 elements. Similarly, as with the strings, everything works with the accessing like the characters in the string. You can also make ranges. You can say that, okay, I want to have every second element of the tuple, so starting from the default position, which is 0, going up to the default end position, which is basically including the last item in the string, and having a step of 2, and then I get basically every second entry. So I get this one, the 0th entry, the first one is ignored, and then I get the second entry. Similarly, if you wanted to, for example, if you wanted to just reverse the tuple, then you would just take -1, and it would just walk backwards. Okay, So basically you can do everything with tuples as we are used. Of course, similar to strings, you should not try to access an element which does not exist. So basically if you say tuple 1, 5, then you get an error. And you also should not try, and this is what he shows here, to change an element, because tuples are so-called immutable data structures. Once they are created, similar to strings, you cannot modify them anymore. So basically, if you have this t1 tuple and you try to set t1, the zeroth element of t1, let's say it's to -1, you will get an error because it says the tuple object does not support item assignment. So basically, you are not supposed to manipulate tuples once they have been created. Here you see a few more operations you can do with tuples. It's exactly the same as with string. If you're applying the plus operators, the tuples are appended after each other. If you're multiplying a tuple, the tuple is repeated. So basically it's one-to-one analogous as we had with the strings. So let's have a look at an example. Just this was our t1 tuple, this is our t2 tuple, and just add them together. If you would add t1 and t2, you get a tuple where basically after the elements of the first tuple, the elements of the second tuple are appended. Similarly, if you look at t1 and I am multiplying t1 by 2, then I would get a tuple which contains the elements of the tuple t1 twice. So basically this is one-to-one exactly the same way as we had before with the strings. Also the assignment, of course, this, you will want to store tuples in variables. Of course you can do that. You can assign a variable a tuple, and that's the straightforward way as we always do in Python. And you can also, if you know how many elements the tuple has, this is basically this here, if you know how many elements the tuple has, then basically you can also assign it element by element. So what does it mean? Let us make this a sample. So let's say my tuple is equal just a tuple 1 and 3, for example. Then this is my tuple. And then if you have, let's say you say v1 and v2 is equal my tuple, then this is an assignment, and it seems that v1 ingot get the first or zeroth character, v2 was assigned or shows to the second character. Of course, this doesn't work if your tuple has more than elements, then it won't work also. If it has 1, 5, 3, 5, for example, then if you try to get all the content, then it will not work because you have too many values to unpack. So you have 3 values here, but you were only providing here 2 variables to unpack the tuple. That's a Python word for that, unpacking the tuple, so then it doesn't work. So you must make sure that the left-hand side has the same amount of element than the right-hand side. If you don't know how many elements a tuple has, then you can just assign it to any value. And then v is the entire tuple. So basically unpacking only works if you exactly know how many elements you have. Good. Now basically the next container, so that already tells us everything which we want to know about tuples, at least at the moment. And I would like to introduce the next container, which are the lists. Lists are absolutely similar to tuples. We can do exactly one-to-one everything as we did so far with the tuples, with the very, very important difference that lists are mutable. That means we can change the content of the list even after the list has been created. So what does it mean for us in the praxis? Let us have a look. Let's go back to our worksheet, and let's just create a list. Again, similar with the tuple, I will just enter some number, some string, whatever it is, and maybe just a floating point number. The content doesn't really matter, and everything works as with the tuples. You can select the elements by with square braces, or you can even select ranges, or you can even, if you want, select step when you select the ranges, and you can even just basically, this is not from 0, but just the default one, you can just also reverse it. So that works everything else as before. However, in contrast to the tuple, I can now basically do the following. I can just modify one of the elements if I want. So for example, I can say L1 0. The 0th element of L1, if you look at here, was basically the number 3, okay? And now I am just replacing it with the number, let's say 42, and I'm executing it, and voila, in the lists it was indeed changed. So the big difference to tuples in L2 is that basically you can manipulate the lists once it has been created. You can also manipulate ranges if you want within the list. That would be the following example. Let's assume I want to say the list 0 to 2. If I just write it, that would be the first 2 entries, and no, I can overwrite it with something. Either I can specify a list instead of that, so I can say it should be the elements 1 and 2. And now if you have a look at sorry, I'm just messing around with my worksheet, but no, it works. If you have now a look at the first 2 elements, you see that they have been replaced. And it's often such that if you have a range here, you can also specify more elements on the right hand side. So let's say -1, -2, -3, -4, and it still works. And then basically if you have a look at L1, you see that the first 2 elements has been taken out and it has been replaced by 4 elements instead. Okay, so you see here that here you have 4 elements instead. So basically that way you can, for example, even extend the list. So basically you can insert elements. Again, addition and multiplication, I didn't do it explicitly in the worksheet, but this is you can do. If you have here multiplication, then the list is basically appended, so that you get the list twice, the elements appended. Addition means that you are appending the items to the 2 lists into a new list. So this works exactly the same as it works with the tuples, and also the length function can be used in order to query the length of a list. So for example, if you ask how many elements L1 now has, there's exactly 4 elements, right? And just to give the example, L1 plus L1 would be a list with 10 elements, which are just the 2 lists appended. Or you could have even written L1 by 2, which is basically the same L1 multiplied by 2. That means the elements twice after each other. Okay, good. As I have demonstrated before, you can modify the lists. So basically that we covered already, and the only thing which you are missing, how you can delete elements from a list. And here there are various techniques, but probably the easiest thing is to use a so-called del operator. Del is there for delete. That means delete a certain element, and you can either specify an element or even a range which you would like to have deleted. So let's have an example for that. Let's go back to our list L1 that has these 5 elements. I can, for example, say delete L1 0. That would delete the 0th element of L1. And if you have L1 and say the 0th element, which was the -1, is just disappeared, right? But it also works with ranges. So you could also say I would like to delete L1, the first 2 elements from 0 to 2. You could of course even leave away 0, because you know if you leave away the left index, the lower index, then it's the default one, which is the beginning. And then if you do that, so 0 to 2, the first 2 elements were vanishing, and we basically these 2 elements has been deleted, and basically we kept only these 2 elements here. So that's very, very straightforward in the sense that the indexing works as before. And as I said, the big difference of tuples is that you can remove elements once the list has been created. Okay, let's have a look what else we want to cover. We would like to extend lists once we have created it. And lists are very, very important structures, and usually you use them when you do not know how many elements you are ending up. So you are doing some algorithm which is collecting things, and you don't know how many elements the list will be or how many elements you will have at the end. And then you can create a list, maybe just an empty list, and then adding the element as long as the algorithm is running. And once the algorithm is finished, then you can manipulate your list, have a look how many elements you collected, and access them one by one. And in order to do that, we need the append function, which does exactly as the name indicates, appends an element to the list. And the other way to extend the list is if you have already a list and another list, you can append the 2 lists to each other. So basically add the elements from one list to the at the end of the others, and that would be the extend method. And then let's have a demonstration for that. Let's define, for example, an empty list at the beginning. Let's call it L5, and that should be the empty list. Similar to the tuples, the empty container is basically indicated by the square braces, so basically the delimiters of the container without any elements within. So L5, if we have a look at L5 and of the length of L5, then it's exactly 0. So let's delete this cell, and now let's say our algorithm collected a number, which is a number 9, for example. Then we say L5.append. So let's append to the list and L5 the number 9. And now if you look at the list, L5 indeed it contains the number 9. Again, if the algorithms run further and it collects a new item which must be appended, let's say 12, then we are just appending 12, and you see that basically here you have no 2 elements, and so on and so on. Sometimes you want to extend the list with more than 1 element at once, and then you have to use the so-called extend method. And the extend method applied on the list L5 means that you have to specify a list, let's say 17, a list containing from 3 elements. And then if I'm executing this and have a look at the value of L5, I see that the 3 elements has been added. So basically append you can need if you want to append exactly 1 element. Extend you can use, or you should use, if you want to extend the list with more than 1 element, with a list of elements. This what we do here is actually, although we didn't say it explicitly, and but this is basically already a kind of object-oriented programming. Here we have the list. This is L5. This contains the data or list, and then there comes a dot. So this is an object containing our list. Then comes a dot, and then we are telling the object what to do with the data it contains. We are calling a method of the object, in this case the extend method, and the extend method we are passing as argument this list with 3 entries. And then what happens is that that L5 will manipulate the object, will manipulate its data, and basically add the data it contains, or extend the data it contains with the elements which are given here. And then if you access the object L5, then you have the content of this object, the data of this object it contains is the extended list. So just this is basically not that important for the moment, just to show you that this is the so-called object-oriented notation, and we will use it a lot because in Python basically almost everything is an object. There is also one thing which is indicated here. You can also do instead of the extend, and basically instead of extend you can also say L plus L5 equal L5 plus something, let's say 1, 2 and 3 or 4, doesn't matter. And then you see that basically if you get the content of L5, you see that basically it has been also appended. But what is the difference between the two ways of doing this? If you write this expression here, L5 plus something, then basically Python will first here take L5, then it will take this list, then it will create from the 2 of them a new list by appending the elements to each other, and this new list is then assigned, or the name L5 is then assigned to this new list. If you do extend instead, then basically Python is not creating any temporary intermediate object, but it basically the L5 gets, the original L5 list gets basically the command extend yourself with those entries here. So there's a slight difference, and usually this one is more efficient because there is no temporary copy made. Actually, there's a third form you can use. You can say instead of saying L5 equal L5 plus, let's say take something 1 minus 1 minus, so that we see the difference. Instead of doing that, you can change the so-called infix notation. So something is equal the same object plus something. This you can here basically abbreviate by the plus equal. This means L5 is equal L5 plus something. And if you now give the content of L5, you will see that the 2 numbers has been appended. And usually in terms of efficiency, this is similar, not necessarily, but similar efficient, especially if you have a long list, than the extension here. Okay. So basically, that's what I wanted to tell you about lists. Lists have a lot of different methods I'm not covering here explicitly, and also tuples have a lot of different additional methods you can apply, and you can just look up in the Python documentation the sequence types if you ever need them. We can also sort the list. That will be important if you make the exercises or one of the exercises at the end of the session. And sorting basically just means we just say apply the sort operation on yourself, and then basically what you will get is a sorted L5. Then afterwards will be a sorted list. Good. And the last thing which I want to tell you about lists maybe is the in operator. So basically with the in operator you can check whether something is contained in the list or not. So if you look at our list L5 here, it contains really a lot of elements, and you can ask yourself, is for example 1 in L5, is the element the number 1 contained in L5? And that's the case. But if you, for example, look in the number 42, whether 42 is in L5, then you will get the answer that's not the case. So basically the in operator, just you give a number or an item in and the container, and if this item is contained in this container, it will be true, otherwise it will be false. You should keep in mind that in lists, in ordered lists, the problem is that if you have a very, very long list and you are applying the in operator, what the in operator in this case does is loops over all the elements here and compares one by one whether they are equal to the operand which was given on the left hand side. And that can be, if you have very, very long list, it's very slow. So therefore this is not the right thing to do. Lists are usually important if you select the elements by position and not by value, so not basically by trying to check whether they are contained or not. Okay. About the object-oriented programming and object-oriented notation, I told you already, so I will just skip this slide. The next thing I would like to discuss with you, because it's incredibly important, especially in Python, if you are dealing with mutable data structures, is the assignment. And if you remember, in the last time we were already talking about assignment, and we said assignment in Python usually can be interpreted as an aliasing, as a pointer. What does it mean? If I write A is equal 1, that means an object 1 is created in the memory, and the name A just points to this object. And if I say B is equal A, then basically there is no new object created in memory, but it means let B show to the same object to which also A shows to. And you see here A to B, that means A and B are showing associated with the same object in memory. And if you basically now having a new assignment, A is equal to, then on the right hand side, this is not a variable but an expression, then basically an object with the value 2 will be created in the memory, and A will point to this object. So far so good. That's not very complicated. Now let's have a look what it means for lists. For lists, the game is exactly the same. If you create a list, L1 is equal 1, 2, 3, 4, and then L2 is equal L1, then basically you will first create an object with the elements 1, 2, 3, 4, and then a second object L2, or a second name L2, which points to exactly the same object as L1 points to, right? Let's have a look at that. So let's say L1 is 1, 2, 3, 4, and L2 is equal L1. And of course, if we list the content of L1 and L2, we get exactly the same numbers. Why? Because they are showing to the same object. And if we are reassigning L1, so we say L1 is equal 3, 4, 5. Let's take the same example as before. Then basically L1 is pointing to the new object, and L2 still points to the old object. So basically there's a new object created 3, 4, 5 in the memory, and L1 will point to that object, and L2 is still associated, points to the old object with the content 1, 2, 3, 4. So this is basically very similar as the assignment before. However, one has to be very careful, because in contrast to the assignment with numbers before, numbers are not mutable, lists are mutable, and therefore this assignment, this pointer assignment, if you want to put it this way, has a very, very important side effect you should definitely aware of, because this is one of the mistakes beginners most often make in Python, because it's not necessarily intuitive. And that happens when you, after the assignment, change some things. So let us have a look at the example first here on the slide. You see that I have here 1, 2, 3, 4. L1 is associated with 1, 2, 3, 4, okay? And L2 is associated with the same object as L1, which means they are both showing to the same object in memory. And if you give out the content of L1 and L2, they would have, of course, the same content. Okay, now let's have a look at that. So we were just saying L1 is equal 1, 2, 3, 4, and L2 is equal L1. Sorry, just as an assignment, L1. And if we just get the content of L1 and L2, we get exactly the same numbers. So far, so good. Now we do something which we didn't do before. We will now change one of the elements in L1. And basically, it's not L1 when we change the elements. L1 is just an alias to the object in the memory which contains the elements 1, 2, 3, 4. And if I say take the second element, which is the third if you count it, because you have to start the counting with 0, it says take the second element and set it to -1. And that means where in the list L1, so basically in the object in the memory to which L1 points to, with which L1 is associated. So basically I will now say here the second element of L1 should have the content, let's say -1. And of course then L1 has changed, that's clear. But if you list L2, you see that L2 changed as well. And this is something you should be always aware. Why did that happen? This happened, we can just have a look at the slides. This happened because L1 and L2, they are showing to this exactly the same object in memory. And basically, they are not independent entities, they are associated with the same object in memory. And of course, if you change the object in memory, it doesn't matter which names are associated with it. All names which are associated with this object, they will show the modified content. So this is a kind of side effect, and this may hit you very often, so be aware of that. Okay, now let's have a look what happens, how we can avoid it. And it turns out we can avoid it in certain situations by making just a copy. So basically not assigning, but making a copy. So let's do the same exercise as before. I will just go upwards here. Here was L1, and instead of saying L2 is equal L1, I will just say list L2 is equal, or L2 is equal list L1. That would basically create a list from L1, which means it will iterate over the element of L1, but create a new list out of that. Now, if I show the content of both, of course, the content of both is the same, but basically the concept in the memory, the pattern is completely the pattern how it's allocated is different. I have creating an object 1, 2, 3, 4 to which the name L1 shows to, and then I was creating another object, a completely independent object, although with the same content 1, 2, 3, 4 to where L2 shows to. And now the two objects are independent of each other. So if I just changed here, as you see, L1 and execute it, then so basically I set the second element to -1, and I show the content of -1. Then indeed the second element, which is the third in the row, is -1. But the original element L2, if I now re-evaluate it, it still has the content 1, 2, 3, 4. And why? Because the two names L1 and L2 are showing now to two different objects. And how do we achieve that? We achieve that by making sure that L2 is not associated with the same object as L1, but a new list is created with the same content as L1, and L2 is associated with this new object here. So they are independent in memory, like as you see here. Unfortunately, this trick doesn't always work, and this is exactly also something you should be aware of. And because this list copy is a so-called shallow copy. What does it mean? So let's have a look at the slides. We will make a new example with L1, L2, two independent lists, and then we will create lists of lists. So let's have a look at this. So we will just go step by step. We will create a list L1, which is 1, 2, 3, 3, and 4. Then we will create an L2, which is just -1, -2, -3, and -4. And we will create an L3, a list where I just include L1 and L2. We will immediately see this is a list of lists, which is absolutely possible in Python. A list can have any kind of items. The items can themselves also be lists. And L4 we will just make it differently as list L3, so basically a copy of this list. Okay, let's execute it and have a look at the contents one by one. L1 is just the list 1, 2, 3, 4. L2 is the list -1, -2, -3, -4. L3 has two elements. You see, the first element is a list which contains 1, 2, 3, 4, and the second element is a list which contains -1, -2, -3, and -4. Okay, and what about L4? L4 was a copy of L3, so I was copying because I was using here the list constructor, so I'm making a new separate list in the memory. L4 has exactly the same element, but we would hope it's different in the memory. And now we will just do the following. We will modify one element of the list L3. We will take out element 0, which is the first list, and within that we will modify element 0. So let's do that. What is L3 0? L3 0, if you remember, or let's have a look first on L3. L3 is this list of lists. L3 0 would be the first item, which is a list itself. So basically, I can take the 0th element of the first item, which would be the number 1, and let's set it to something else. Let's say to the number 9. And now let's have a look on L3. And L3 indeed is a list of lists, but the first item, the first item of the first list has been changed to 9 because I have taken the 0th item, which is this list here, and within this list I was setting the 0th item to 9. So far so good. This basically is what we maybe expected, but if you have a look now on L4, here it changed again, despite the fact that we were here asking Python to make a list, so a copy of L3. So you could ask yourself, why does this happen? And it turns out because Python usually makes a so-called shallow copies. So basically, if you look at here, it's everything shown. We first created an object L1, which is in memory, then an object L2, which is another object in memory and associated with the name L2, and then L3 was basically L1 and L2. But what does it mean? It's not the content of L1 and L2 which are inserted in L3, but it's basically the pointer, which means here the first element should point to the same object in memory like L1. And here we wrote L2, which only means the second element of L3 should point to the same object as to which L points to. And then we were creating L4, and indeed it was a different object in memory. However, this different object contained again only two pointers. The first pointer pointing to the object to which L1 points to, and the second pointing to the object to which L2 points to. That means if you change here the first element of L1 as we did, then basically whenever you have a pointer to that, then it will change those automatically. So despite the fact that we were copying the list L3, it's a so-called shallow copy, which means it just made a different object, but it contains the same pointers. So basically just what you have to remember here, which is very important, that mutable object can have side effects because assignment in Python is just aliasing. It's a kind of pointer which points to an object in memory, and that can have side effects even if you make copies. If you really make an absolutely independent copy of two objects, then you can use the deep copy in the in the module copy, and that would make sure go through the list and the list of lists and whatever in the list contain, and make sure that for everything there it makes a separate object in memory, and then the two things are independent from each other. However, most of the time that's not what you want, because you usually do not want to have shallow deep copies. So usually if you think about deep copies, maybe you should rethink your algorithm. The drawback of deep copy, of course, it's slow if you have very big structures, while this aliasing is incredibly fast. Okay. So the last few things about tuples and lists, again, we discussed that already, so we can just very quickly go over that. If you add two lists, which we discussed, they are just appended, and this is exactly similar to tuples. So in that sense, the two things are very similar. Also, the multiplication, we had that already in the worksheet. You can do, if you just multiply it by a given number, then basically that would mean that you are repeating the list or the tuple exactly that many times. And we also had already the in so-called in-place operations. So basically, instead of writing instead of writing A is equal A plus B, you can write A plus equal B. The same with the minus, with the multiplication, with the division, or with the integer division. So those all works in this so-called in-place format. And then the last thing which we already discussed, if you have a long list and a short list, then basically instead of using an explicit addition which would create first a new list, a new temporary list or a new object, and then basically here assign the name long to that. Instead of that, you can use the in-place operation, which say just let's make long being the same as long plus short, which is short, and often much better, and does not make temporary copies depending on the situation, or even much better if you have the extend method of the long list. Then basically it will be absolutely in place in the sense that it will manipulate the list without creating any extra objects. And with that, we finished basically tuples and lists for the moment, and we want to go ahead for an even a very exciting structure container, which is the so-called dictionaries.